Hello everyone, today we're going to be doing 2014 Aime I problem 15. In triangle ABC, AB equals 3, BC equals 4, and CA equals 5. Circle omega intersects side AB at E and B, side BC at B and D, and side AC at F and G. Given that EF equals DF and DG over EG equals 3 over 4, length DE equals A squared of B over C, where A and C are relatively prime positive integers and B is a positive integer not divisible by the square of any prime. Find A plus B plus C. So we need to find DE in simplest form. So here we have our 3, 4, 5 right triangle where AB is 3, BC is 4, and then AC is 5. We have our circle going through B, and then it intersects at E on AB, D on BC, and then F and G on AC. And we're given that EF equals DF. So EF equals DF. And then DG over EG is 3 over 4. So DG over EG is 3 over 4. Now, since we don't know the exact value, we can call this 3R and 4R. And we're asked to find the length of DE. Now, first I see that DE is the hypotenuse of triangle EBD. So I'm going to define EB as A, like the length, and then BD of length B. And then we can do Pythagorean theorem on that to solve for DE. Now I'm going to look at the angles within this circle. I see that EBD is a right angle, which means that ED is the diameter of the circle. By inscribed angles, this means that EFD is also a right angle, and EGD is also a right angle. Oh, but looking at triangle EGD, we have that their lengths are in the ratio 3 to 4, and it's a right angle, which means that this is just a 3, 4, 5 angle with some ratio. This means that we can call ED 5R. Now, matching the angles of EGD with ABC, let the single arc represent angle A, and then double arcs will be its complement. On the smaller triangle EGD, we will have that EDG will be a single arc, and then DEG will be double arc, or its complement. Now we will look at more inscribed angles within the circle. We have that DEG is equal to DFG by inscribed angles. We also have that we have looking at this line over here, we have that all the angles will add up to 180. But because this is 90 here, and we have the double arc here, we have that this angle here must be the complement of the double arc angle, which means this is just single arc. Now looking at this, we see that AEF is isosceles, which means that AE equals EF, and we have that FDC is also isosceles, which means DC equals FD. Now we just need to solve for that equal side. Knowing that ED is the diameter. I can drop this altitude here. Where I will have that the foot is going to be the center. My radius is going to be 5r divided by 2. Now, because this was an isosceles right triangle, that means it was a 45, 45, 90 triangle. And when we divide it into 2, it's still a 45, 45, 90 triangle. Because the height here is also 5r over 2. This makes the hypotenuse there equal to 5 square root of 2 over 2r. And the same thing on the other side. And because these are of equal length, we will have that this is also 5 square root of 2 over 2r and 5 square root of 2 over 2r. Now we actually have enough information to get 3 equations with 3 variables. My first equation will be the segments that add up to line AB, segment AB, which is 3 is equal to 5 square root of 2 over 2r plus a. Now, adding the segments to equal length BC, we'll have 4 is equal to b plus 5 square root of 2 over 2r. And then finally, I have the right triangle EBD, where I have a squared plus b squared equals 5r squared, which is 25r squared. Now, first I'm going to take these two equations and subtract them together. This will give me b minus a equals 1, which is the same thing as b equals a plus 1. Now I'm going to take this and plug it in here for b. So this gives me a squared plus a plus 1 squared equals 25r squared. Expanding this out, I get 2a squared plus 2a plus 1 equals 25r squared. Finally, I need to get this equation in terms of only r. So then I'm going to take my first equation here again and write a in terms of r. This gives me a equals 3 minus 5 square root of 2 over 2r. And now I can plug this in here. This gives me 2 times 3 minus 5 square root of 2 over 2r squared plus 2 times 3 minus 5 square root of 2 over 2r plus 1 equals 25r squared. And we'll just keep expanding this. Notice that the 25r squared and the 25r squared cancel out on both sides, which reduces it to a linear equation, which will be very easy to solve. Combining like terms, I have my constants here. This will add up to 25. And then I'm going to take these and bring them to my right-hand side so that it'll be positive. And finally, solving for r, we get 5 over 7 square root of 2, which is equal to 5 square root of 2 over 14. But that's not our answer. We're asked to find DE, and DE is equal to 5r. DE equals 5r, which means we're going to take 5 times of 5 square root of 2 over 14, which is equal to 25 square root of 2 over 14. And this is in simplest form. So now all we have to do is just add a plus b plus c, which gives us 25 plus 2 plus 14. And this equals 41. And that is our answer. Thank you for watching. Have a nice day.